Milestone 2 is a task to push the limits of what we could do with the robot. We wanted to see how far we could go with the hardware, the software, and the systems on the robot, and whether we could do a certain set of tasks reliably. The robot has to open doors to get into offices. The task inside the office is to plug itself in to an outlet that's available in the office, and the robot needs to do this multiple times and not fail a single time.
In the Milestone, we start with two pieces of information. We start with knowledge of the building in the form of a map and approximate knowledge of where the outlets are located in that map.
From the map, it knows approximately where the doors are. It has a tilting laser sensor on the head of the robot, which creates a 3D representation of the world around it. So it takes that 3D information, looks for big planar patches, and then finds the best patch that it thinks matches the door information. Once it has a door, it can go on to try and find the handle. For this, so it uses the laser scanner as well as the camera. If the door is closed, the first thing it'll do is drive up to a spot from where it can reach the handle. It then uses the arm to reach out and grab the handle where it thinks the handle is. As it's doing this, there's several checks running in the background to make sure that the robot is actually grabbing the handle. Once the robot has opened the door by a small amount, it needs to now drive through the doorway while at the same time opening the door out with the arm. It uses the arm to push the door out of its way, and at the same time, the base drives through into the room.
From there, the robot looks up in this map the approximate locations of the outlet it wants to drive to, and then drives to that point. It then starts looking for the outlet using the stereo camera. Once the robot's in front of the outlet, it then uses the 5-megapixel camera to get the exact position and orientation of the outlet. This is a difficult step for the robot. We're using a monocular camera, and it's very hard to accurately judge the depth to the outlet. The robot uses the tilting laser scanner to scan the base of the robot and determine the location of the plug. Currently, the plug is held on the base of the robot using a set of really strong magnets. After the robot picks up the plug from the base and has it in its gripper, it moves the plug to a location near the outlet. The robot uses the 5-megapixel camera and the checkerboard on the outside of the plug to determine, using an algorithm, the orientation and position of the plug. It then tries to plug in, first by servoing into the outlet, using the visual difference measured in the 5-megapixel camera frame and trying to position the plug directly in front of the outlet and plug in. If this fails, we then go into somewhat of a recovery behavior where we try and brute force plugging into the outlet by spiraling outwards from the best guess of the outlet location. After the robot is sufficiently charged, the robot wiggles the plug out of the outlet, and wiggling is a very unscientific term, and that's really what we're doing.
The main issue here is to test robustness. So the robot is completely autonomous. There is no human intervention allowed at any point. A bunch of people were pretty nervous, including me, about what would happen.
When the robot finished the milestone, I was relieved.
People were trying to mess with the robot as well as it was doing the task by jumping in front of it and trying to make it mess up, but it never did. So it's a persistent robot. It keeps trying until it does what it needs to do.
Milestone 3 is in the making, but mostly it's focused on making the robot available to other people in the open source community and getting the robot ready for prime time.
This is the whole goal of this company and this program. It's to provide people with a platform so that they can do the basic tasks much easier.